but hopefully sometime in the future that could happen. My name is Wei Jie. I currently work with the Ethereum Foundation on Applied Zero Knowledge projects. About 2 years ago, I came to FKL also to present at one of the meetups at the co-working space, and I have very fond memories of that trip. And at the time, I presented about a zero knowledge proofs for the Mastermind board game, and at the time, that was the beginning of my journey doing zero knowledge things, and that's when I was a smart contract and backend developer for Consensus Singapore. Today, with the Applied ZKP team, we work to bridge the gap between ZKPs and application development on Ethereum. And so we are always on the lookout for use cases that can benefit from ZKPs and also new research directions that can benefit from engineering expertise. And in this team, I helped to build a project called Semaphore, which is a privacy gadget that lets developers build mixers, anonymous login, and anonymous voting systems. And besides that, I also work on trusted setup ceremonies. And this is a team comprised of myself, Barry Whitehead, Koh Wei Jie, and others. And my role is mainly as a software developer and also a tiny bit of research. And beyond work, during the lockdown, I have enjoyed doing a lot of reading, running, taking hikes, and learning new things. So just want to give some credit to the people who made MACI possible. Vitalik came up with the original concept, and Barry and Kobe led the research efforts and also gave a lot of technical advice. And Kendrick, Zhicheng, Ying Tong, and Ying Tong also did development work for MACI. So today's presentation is not technical in nature. I will cover the concepts around MACI at a more general level. But since this is an Ethereum meetup, I do assume some basic familiarity with Ethereum and smart contracts, but I won't get into a lot of technical detail. Maybe if people are interested, we can do that at the end of the session, maybe if there's a Q&A. But mostly I want to focus on the fundamental nature of the issues that MACI tries to solve, and also elaborate on the use cases that MACI can benefit. Harith, can I just clarify how much time has been allocated for this?
We put it until 9:30, but okay. Honestly, it's remote, so as long as people are still awake, we can go on.
Okay. I probably can finish before 9:30, but I'm like super happy to be there for the do a Q&A, and if there's any questions in the middle or at the end, please anybody can feel free to chime in, and I can just pause anytime and clarify or answer questions. And maybe during the end of the session, after the presentation, we could do a discussion kind of format where so it's like more free flow. Yeah. Okay, so let's just talk about the main problem that MACI tries to solve, and that is bribery. But specifically bribery in public blockchain voting systems. So the reason that bribery in these systems is even possible, it's not just that people can be bribed, or that people are dishonest or greedy, or they don't want to play fair. The key issue here is that in public blockchain voting systems, you can prove that you voted a certain way. So if you show your bribe your vote, they can verify it. And then if you had voted for the party or the option that they wanted you to vote for, they can pay you the money, which is the bribe. So a very, very simple example is Eve is a briber, and she says, Alice, please vote for party A. And I'll give you 5 ETH if you do that. So Alice says, okay, and then she votes party A, and that's some kind of on-chain transaction that where she votes for party A. So Alice shows Eve the transaction hash, and Eve looks at the transaction, and says, okay, I can verify that you actually voted for party A, so here's your 5 ETH, and she transfers the bribe to her. So that is what I mean by on-chain public blockchain voting systems. And it can get even more interesting, because bribery on smart contract systems can be done through smart contracts. So, for example, there was this smart contract developer who created something called sell out DAO, and it's sort of a bribery layer in between someone and Moloch DAO, which is a public goods funding mechanism on Ethereum. And the idea is that as long as someone sends like 0.5 ETH to this contract, they can get included in the list of voters for Moloch DAO. And that is a kind of bribe that's made possible by a smart contract and the smart contract logic. Okay, and so that's for blockchain voting systems, but I just want to spend a tiny bit of time to talk about what is the alternative, what is non-blockchain voting systems, and I think everybody is familiar with that. And so, for example, in Singapore, we don't have e-voting, we use paper to vote. So what happens is you go to the voting station and you go to a shielded booth, like the one in the picture, and then you cast your vote, which is on paper, and then the paper votes are counted, and that's where the results come from. And during this process, no one can easily look over your shoulder, and there are also bureaucratic and administrative safeguards in place that are meant to heighten secrecy. And during the whole process, there are also opportunities for local political parties to observe the counting of votes. And finally, after 6 months of the release of results, all the ballots are destroyed. And so this means that only an extremely resourceful and determined attacker can effectively bribe someone to vote the way they want to, as long as these procedures are followed correctly. So that's paper voting. And there's also what's known as e-voting. E-voting is, so for example, at the national level, certain countries use machines to vote. So you go to a machine, you press a button, and that's your vote. The issue with e-voting is that it's a bit of a taboo topic in the security community, because there have been like countless reported cases of e-voting systems malfunctioning or being hacked, even during the actual voting process. So these security problems come from hardware and software, and because they can be complicated, this complexity compounds the risk. And as e-voting also comes in the form of using your own device to vote, but there are accessibility issues with this, especially if you want to do elections at the town level or city level or national level, because not everyone has these devices or access to these devices. So this is not to say that paper voting is perfect. There are paper-based elections, and their integrity in some cases are definitely suspect. And this is due to social factors and political factors. But there is one advantage that paper voting has over e-voting, which is that paper voting is more resilient and e-voting can be more fragile. So for example, if there's some kind of technical flaw in an e-voting machine, it's likely to affect the entire range of machines, or all the machines that are used in this election. But with paper voting, if someone finds an issue in one polling station, they could take action to remedy it and implement some fix. But this is much less feasible when it comes to using voting machines or for e-voting. All right, back to MACI. What I'm trying to say is that MACI is not meant to be an e-voting solution. It is meant to demonstrate a solution to one part of a larger problem, and specifically on-chain bribery. So it covers use cases like DAOs, quadratic funding, and on-chain voting for these organizations. But there's still much work to be done to make MACI and MACI-based systems secure, user-friendly, and performant. It also needs an identity solution to prevent Sybil attacks. And like many other cryptocurrency applications, users need to have good key management solutions. So MACI is just one piece of a larger puzzle. And earlier I mentioned that e-voting is sort of a taboo topic. And when Vitalik wrote about collusion and bribery on in blockchains. His argument was that it's better to try to solve the problem than give up entirely. Because a lot of people in the security community say, don't use online voting, don't use e-voting. But Vitalik's point is that we should try to solve the problems rather than give up. And MACI is one example of a best effort attempt to solve part of the problem. Okay, so here's a concrete example of an on-chain voting system where anti-collusion or anti-bribery is really important. Gitcoin is a startup, and they've been very involved in facilitating funding for public goods on Ethereum. And they do this in multiple rounds. I think people in this meetup have heard of them. And there have been cases where projects that are seeking funding have kind of like offered quid pro quo benefits to people who vote for them. And the idea is that there is a funding pool where there are large organizations like Consensus or the EF that would match donations to these projects. So let's say I donate one DAI, they could be matched more than one DAI by those organizations. So when the project wants me to vote for them, they could say, hey, Wei Jie, please vote for me and I'll give you like special access to my product, or I could give you some kind of benefit. And that is what bribery is, because if I vote for them, they don't just get the funds from me, they also get matched funds from those organizations. And this is this kind of behavior will render this process very problematic, and it's something that people don't want for the good of all projects. Okay, so now that we've discussed like what exactly MACI is tries to prevent, let me explain how it does so in a very high level way. So what does MACI bring to the table? If you take away only one thing from this presentation, the idea is that MACI allows a voter to cast a vote in such a way that it's impossible to prove to a briber. So going back to the example from just now, when Alice cast a vote and showed Eve a transaction hash, if you use MACI, Eve should have no way to tell which party Alice had voted for. And there are two reasons for this that MACI makes possible. First of all, the votes are encrypted. So Alice could say that she had lost a private key that she had used to encrypt it. But what if Alice gives Eve the private key? Here comes the second reason that we can prevent bribery. In MACI, Alice can secretly change the public key associated with her voter identity before she gives Eve the power to vote on her behalf. And so any votes that are cast using Alice's old key will be invalid, but Eve cannot tell whether it's invalid or valid. And so that's how MACI makes it possible for Eve to think, I have no way to tell if I give 5 ETH to Alice. I have no way to tell which way Alice had voted. Therefore, the 5 ETH that I bribe Alice with, it has no effect. I have no way to know if it's going to have an effect. So I might as well not bribe Alice. And that is the key reason that MACI does what it's supposed to do. Maybe this is a good point where if anybody has any quick questions, I could pause and answer those questions. Yeah.
I have one question. Allegedly, some political parties in Malaysia have given sort of bribes to certain sort of constituents. And in those cases, they have no way of knowing that the people who received the bribes voted for them anyway. But we've, again, allegedly seen that that has happened for many years. So would having some sort of on-chain kind of like not being able to track bribery, how much impact would it make in a kind of voting situation like I described?
Wow, that's a like fantastic question. Um, wow. I think the difference between on-chain voting and political voting on the ground in real life, the difference is that in real life there are probably more social connections between the voters and the candidates, and they probably have more kind of like intelligence on the ground. They probably have more ability to influence the voters. So the nudge they give them is not just a bribe, but also like the promises and the things they say to them, the communication, and 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 also in the relationships they have with the voters. Um, I think with on-chain voting, the situation is different because in the crypto community, people are quite spread out all over the world, and there isn't necessarily this kind of deep social bonds or community bonds that people can use to kind of influence others, influence voters with. So people are more kind of spread out and disconnected from each other. So I think that's where the difference is now. Yeah, I hope that makes sense. But then again, then again, it's totally possible. Let's say Eve tells it's totally possible for Alice to do what Eve wants, even if Alice cannot prove it. We can't stop that. We can't stop Alice from doing what she wants. But what we can do is to make it impossible for her to verify for Eve to verify that Alice has voted this way. And I think that's the practical advantage that we are trying to provide. Anything beyond that is has to go into psychology. Yeah.
Okay, Quentin has a question. Quentin, you can unmute yourself.
Hi guys, thanks
Hi.
Wei. I think you should come more often on. Every 2 years a treat. And thanks Harris for making it happen, and Jason and guys. Yeah, just a question. I lost you a bit when you were mentioning the example of Gitcoin. So they implement quadratic funding, right?
Yeah.
And then MACI would be something they could implement, or are they implementing it already? And then I just wanted to make a small observation regarding just the answer you gave. I think to Harris' point and to your point, we can't stop physical bribery. So in the example of elections in a country, I think you can't stop a politician from, giving money to his constituents, basically, because he already doesn't have the proof that they will do so, as Wei said. I think if we had MACI from an election through an online election in Malaysia, for example, the case scenario and the question would be, if a state-controlled commission organizes the election, the fact that we implement MACI, would it mean that even that institution that is holding the election is incapable of knowing who's voted for who?
Okay. I will maybe just take the second question first. So I think generally I wouldn't say that MACI is currently at a place where it's feasible for national elections or political elections right now, because the name of the project is Minimal Anti-Collusion Infrastructure. So it's really an MVP software project, and I think any kind of e-voting system has to go through so much testing and so much development work to be even feasible at national level. So I can't make any claims about like whether this could work nationally, because I think there's so much engineering to do to even make that possible. When it comes to whether to the relationship between bribery and the so-called election commission. So in MACI, I'm going to explain a bit more later. There is a coordinator, and we assume that the coordinator is trusted. And this is an assumption that's built into the system. and it's something we can't really avoid. So I'll explain why later. But when it comes to MACI, we assume that the coordinator is trusted. But even so, we only trust that they don't collude with bribers. We don't assume that they can. We know that they cannot censor the votes, and we know that they cannot miscount the votes. All we assume is that they won't bribe. They won't be bribed or collude with other people. And as for your question about Gitcoin, Gitcoin, as far as I know, has not used MACI yet. But there's another project that I'll mention later called Clear Fund that are building a public goods funding mechanism using MACI. And I think it's still early days to see, it's currently still early days. So hopefully we can get adoption for this project from many sources. Yeah. I hope that answers the questions.
Very much so. Thank you. Thank you very much.
Thank you. All right. Should I keep going?
Yeah, should be good.
All right. Awesome. I will send the link to these slides to Harith, and I do have a recorded presentation that does a full technical deep dive, and you can find this on YouTube if you search for Minimum Anti-Collusion Infrastructure. But without the technical explanation, I just do a very, very basic overview of how this works. So it's very similar to in real life. There are a few steps. First, the users have to sign up, and then they can cast their votes. And at the end of the voting period, the coordinator processes the votes and tallies all the votes. And by tally, I mean count the votes, and then they can publish the results to say that party A got this number of votes and party B got this number of votes. We only trust the coordinator to not collude with others, and we also trust that they won't withhold or delay the message processing and vote tallying, because the only party that knows the contents of all the votes is the coordinator. So when I encrypt my vote and send it to the coordinator, only I and they can decrypt it and see what I voted for, and no one else can see that. So we know that they have access to all the votes, and they are the only person who can count the votes because only they know all the votes. But they cannot process or tally the votes incorrectly, and they cannot censor the votes. So the reason that they cannot censor the votes is very simple. We use an Ethereum smart contract to store the encrypted votes. Not really store the encrypted votes, but we submit the votes as a transaction to the smart contract. So you can't censor that. And they cannot process or tally the votes incorrectly because you use something called a zero knowledge proof. The coordinator must provide a proof that they have tallied the votes correctly, and this proof is verified by the smart contract, and they cannot proceed if the proof is invalid. They must provide the valid proofs all the way until the end of the tally process. And it's because all the proofs are valid, then we know that they tallied it correctly. There's no way for the tally process to happen if there are invalid proofs. So the worst they can do is to not tally the votes. But that's not really, but we assume that they are going to do that. Yeah. But we definitely know that they can't mistally. And so why do we know that the coordinator can be bribed, but they cannot cheat? So this slide is just a summary of what I mentioned. We know that the coordinator can decrypt all the votes, so they, in theory, could be bribed. And so we have to assume that the coordinator is trustworthy. But we know that they cannot cheat because we use a smart contract where votes are sent as transactions, which are uncensorable, and we use zero knowledge proofs to ensure that the tally is correct. So I think I want to just spend a tiny bit of time to explain what goes on in a zero knowledge proof. So the idea is that you can show that you did some kind of formula without showing the contents of the inputs or some of the inputs. So let's say that I have a list of numbers and a hash of the list of numbers, and let's assume that everyone agrees that the hash is correct, but they don't know what the numbers are. And I want to show that I know the second number. So I could so the formula is to hash all the numbers and check whether it's equal to the hash that people agree on. I want to hide the first number and the last number, but I want to show the second number. So for this proof, the public data is the second number and the hash, and the private number is the first and last numbers. And then the formula is just to hash all three numbers and check that it's the same. And the proof basically says that I have executed this formula correctly, and the proof does not show the private data. So I can make a claim about some kind of computation without showing the contents of the data. And for MACI, we want to make a claim that we counted these votes correctly, but we don't want to show the votes themselves. And zero knowledge proofs allow us to do that. And I think because I don't want to go into too much technical detail, that's the kind of the basic overview of what this is. Maybe I should pause here if anybody has any questions before I keep going.
Do you have like an example of a zero knowledge proof, or like a metaphor for a zero knowledge proof?
Yes. So let's say an example is, let's say I have like a balance of oh, have you heard of Tornado Cash? Okay, so for example, I use Tornado Cash as a mixer. I mean, I don't, but if someone uses Tornado Cash as a mixer, if I did, I wouldn't say, right? So what they do is that they deposit some ETH into this box, and then let's say that all the balls, let's say they put some coins in a jar. Okay, so these coins are ETH or tokens, and all the coins have different colors. You put in all these multicolored coins in the jar, and each person put in one coin. Okay. What the zero knowledge proof does is make all the coins the same color. So when you take out the coin, you only need to prove that you put in a coin in the first place. But because it's the same color, you can't tell the difference between all the coins, and you can't link your original coin to the coin you took out. Another example is, let's say that you have a bank. This is like a super simple example. It's not very accurate, but let's say you have some money in the bank, and you want to prove that you have less than $10,000, but more than $5,000. A zero knowledge proof would hide exactly how much you have, but it will help you to show that you have some amount between these two numbers. Yeah.
Okay. Hi guys. So say I wanted to be able to build a voting app. And I wanted to be able to, so like each person casts a vote. We need a proof that I need to be able to prove that firstly, the person is eligible to vote, and secondly, that they haven't already voted. Could you do that?
So in MACI, we don't use the zero knowledge proofs for those two cases. in MACI, when the user signs up to vote, what happens is that they register their public key with the system. And when they cast a vote, they could use a different Ethereum account, and no one would know who the original voter was. But that's not why we use a zero knowledge proof. The reason we use a zero knowledge proof is to ensure that the votes are tallied and counted, are processed and tallied correctly. Would you mind repeating the second question?
Yeah, I mean, basically, what I wanted to prove two things. Firstly, that the person is eligible to vote, and secondly, that they have only cast one vote.
I see. Okay, so in MACI, we don't use zero knowledge proofs to prove eligibility, because that is done in a public fashion. In MACI, the developer can implement some kind of smart contract logic to allow or deny any address from signing up, and that has nothing to do with the zero knowledge proofs. And we don't have a limit on the number of. We don't have a hard limit on the number of votes a user can cast. So in fact, you can cast multiple votes. So we don't use zero knowledge proofs to prove that they had cast only one vote, or they had never cast a vote before. So yeah, I apologize for any confusion with the examples. In the example of a mixer, you need to prove that you had made one deposit that hasn't been withdrawn yet. But in MACI, we use zero knowledge proofs for something entirely different. Yeah.
Is there a reason why with MACI we're not using zero knowledge proof to check that they voted multiple times, or that we don't have a maximum cap? Is that like on purpose or just technical, keeping it simple?
Okay, so it's both on purpose and technical. The reason that we don't have there is a cap on the number of messages, and that's but it can be set to quite a high number. But practically speaking, you could vote 10 times, 20 times, depending on the way the system is configured. The limit is not very low. It depends on the capacity that we set inside MACI, and that's a setting. So it's not unlimited, but it can be quite high. And the reason that we allow people to vote multiple times is that let's say that Eve bribes Alice. Okay, so what Alice does to prevent Eve from bribing her is first she casts a vote for what she does is first she casts a vote, and this vote is a kind of a special vote. It votes for nobody, but it changes her key to a new key, and then she uses her old key to vote for the party that Eve wanted her to vote for. And then she shows Eve the transaction, and Eve has no way to tell that that vote is actually invalid. And then Alice uses her new key, which is valid, to cast a valid vote for a different party that she wants. So Alice can vote many times, and each vote can be invalid, it can be valid. And we use the invalid votes to kind of fool the briber, because they have no way to tell if it's valid or not. Yeah. But at the end of the day, all the votes are counted and aggregated by the coordinator. So it's different from a political election where you only have one piece of paper. In this election, you could have like 5 pieces of paper, and 2 of them are sort of like invalid. And you only show the briber these 2 invalid ones, and the other 3, they don't see it. But at the end of the day, it's all counted. Yeah. Okay, should I keep going?
Ray asked in the chat, only 1 of the 5 votes are valid? How do you guarantee that only 1 vote is valid?
So the logic that checks whether a vote is valid or not is part of the zero knowledge system that we use to tally the votes. If the coordinator counts an invalid vote as valid, then the zero knowledge proof will not be valid. And so it's impossible for them to miscount it. Yeah. I should look at the chat room, but I don't know how to see it. Are there any more questions I should take? I can't really access the chat room.
Yeah, it's not from the chat. I'll share if there's any from the chat.
Oh, okay.
There's a horizontal bar you can kind of like see. Then there's one of them has a more, and you can click chat. But I think you can just go ahead and we'll let you know if there's any questions in the chat.
Okay, thank you. So, all right. So as previously mentioned, you use the zero knowledge proofs to ensure that the counting is done correctly. And we also, but the secondary function is that there's some level of vote secrecy. There are also a lot of technical considerations around zero knowledge proofs. This is a bit out of scope for this presentation, but we use this thing called ZK snarks, and ZK snarks are currently the most widespread way to do zero knowledge proofs on Ethereum. They do require something called a trusted setup ceremony, and we have not done this for MACI yet, but we have tools at our disposal that can make this possible. And we have run trusted setups for other circuits before, and this can be done for MACI when the time comes. And so there's also future work to be done with MACI. First of all, there is one major flaw, which is that what happens if when you sign up, you take the briber's public key and sign up with that public key. Basically signing up with a public key that doesn't belong to you, but belongs to the briber. That is where we need something beyond MACI, which is some kind of identity proving system that allows you to, where some other people can, when other people can verify that you truly own the public key you're signing up with, and that's a whole new project in itself. There is some resources about this that Vitaly has written about, and I think there are some other projects that try to do this, but it's really beyond the scope of MACI. But hopefully, in the future, these things can work together. There's also future work in terms of setting up user interfaces, and one interesting use case that we are thinking about is something called a quadratic dollar homepage or quadratic $1 million homepage. So this is when, like early on in the earlier days of the internet, someone made a website where they sold each pixel for $1, and there were 1 million pixels, and he sold all 1 million pixels to random people online. And this is how he earned $1 million. It's called a $1 million homepage. So the idea here with MACI is that, let's say we have a bunch of images on the website, and people can vote using MACI on these images, and the images will increase in size quadratically depending on the number of votes they get. So that's one of the use cases that we're thinking about that's beyond quadratic funding, and it's kind of experiment that we are thinking about doing. And we are also like very happy to hear about like any other use cases that can come up. This is ClearFund. ClearFund is a team that is building on top of MACI, and I would encourage people to check them out. And there's also more resources about MACI. They started off with this started off with the ETH research post, and then we work on the specification, and finally we work on the source code for the MVP. And that's it for this presentation. And I'm please ask any questions. I'm happy, and let's have a discussion. Yeah, and thank you so much for having me again.
I have a question, guys. Like, I want to know like how you are actually managing the signature aggregation.
Oh, we don't do signature aggregation. We do, when I mean aggregation, I mean counting of the votes. So let's say I vote for party A in one vote, using one vote, and then I vote for party B in a different transaction. The vote tallying will count both of these votes. And at the end of the day, it knows that I voted for these two parties.
Okay.
I do have one question. So, in order to use MACI, is it necessary to in order to use MACI, I suppose it's on Ethereum blockchain. So you are relying on Ethereum to do like the transparency of the votes, right?
The uncensorability.
Yeah.
Yeah.
So you can't use MACI outside of Ethereum. Is it?
We wrote MACI using Solidity, and we rely on the Solidity contracts to do the logic, and also the ZK snap verification. I'm sure that there are other systems that support the EVM. So technically, it could be possible to use other chains.
As long as the EVM compatible, you can use MACI.
Yeah, exactly. Because EVM, as long as the system supports the Istanbul hard fork which is the current the version of the EVM, yeah, that supports ZK snacks as well.
Okay, thanks.
Yeah.
Wei Jie had a question on the multi-party trusted setup.
Yes.
Without going into, as if possible, without being technical, could you explain why there is a need for a multi-party trusted setup?
Yes. So the way that ZK snacks works is that you can do this kind of cryptography sort of magic using ZK snacks, and in order for that to be possible, you need to do something called a trusted setup ceremony before you deploy the system. And in this ceremony, what we are doing is we are generating some secret numbers, and these secret numbers have to do with the cryptographic keys that are used for the ZK snacks. So yeah, we can generate these keys, but during this process, you also generate this thing called toxic waste. And toxic waste is a piece of data that if you don't discard this data and someone else gets their hands on this data, they can create ZK snap proofs that are valid but are fraudulent. So they could create fake proofs, and they could cheat at the system. So we need a way to generate all these ZK snap keys while secretly discarding this piece of data. And what a multi-party trusted setup is that you have a bunch of people, and they take turns to do this key generation. Not really key generation, but to do some kind of like computation and where they generate the numbers that are needed to produce the keys, and they take turns one by one. It's like a chain, and as long as one of them discards the secret number, then no one can create any fake proofs. So as long as one person does that, discards it, then the whole thing is safe. And the reason that we do it as a multi-party computation is that we want as many people as possible, because the more people, the lower the chances of all of them keeping the secret number. as long as one person discards it, then it's safe. That's why we need as many people as possible. And so that's kind of it's something that Zcash did and I would encourage people to check it out. So what they did is that they opened up this ceremony to the public, and they could sign up to do this. And someone from the States, what he did was he took a piece of Chernobyl radioactive material from Chernobyl, which is the old Soviet nuclear reactor that exploded, and then he used a Geiger counter to take the random data from the radioactive decay of this piece of material, and then he plugged it into his laptop, and he and his friend went on a plane, and they flew around for a while just to see if no one's following them, and they generated the numbers using the laptop in the sky from a piece of radioactive material, and then they landed and then submitted their contribution to the ceremony. And Zcash has more than 70 of these contributions, but not all of them are as fancy as that one. But the point is that the more people do this, the more likely that the whole thing is safe. And you could do it in very special ways that are quite interesting.
So if I put it another way, if I was like some sort of paranoid maximalist that's saying that, this thing can't be trusted, as long as one person out of the whole like N does it right, then it's safe.
Does it right meaning that they don't hold on to the secret. So anybody who doubts the system should participate, because as long as you didn't keep it, you can trust yourself, right? Yeah, so definitely we want to encourage participation. We have 2 ceremonies going on for other projects, and anybody who wants to try this out can please get in touch with me, and I'll get you included.
Maybe you can explain on these 2 other ceremonies that's running, what it is absolutely. And how to participate.
The first one is for Semaphore, which is a privacy gadget that we developed for Applied ZKP at the EF. And Semaphore is something that you can use to implement different kinds of privacy-focused applications on Ethereum, such as mixers or anonymous voting or anonymous login. And the idea is that you can use Semaphore to prove that you're part of a group of people without showing your original identity. So for example, if you are part of a DAO and you want to vote, and this is not MACI, okay, so this is a one person, one vote system, and collusion is possible. So it's just a very simple kind of voting. You could have a system, you could use Semaphore to vote for some kind of proposal in a DAO and let's say 10 people vote on these proposals, on a proposal, but you won't know who voted for whom, or you won't know who voted for what. You only know that at the end of the day, there are 10 people and here's the result. Semaphore allows you to do that. And we are doing a trusted setup ceremony for Semaphore. That process can take less than 20 minutes on the laptop. And we have and there are instructions online that I can point you to do that. The second ceremony that we're doing is called the Perpetual Powers of Tau ceremony. So what is this? The idea here is that for ZK Snarks, there are for any kind of, when you want to do a trusted setup ceremony, you have to do it's 2 phases, phase 1 and phase 2. For Semaphore is phase 2, and Perpetual Powers of Tau is phase 1. But any project that does ZK Snarks on Ethereum can benefit from the phase 1 Perpetual Powers of Tau ceremony. So this ceremony, you can take this output and use it for your project's phase 2. And anybody can use this output for their own project to do a phase 2. So we are saving everybody the time and effort to do a phase one. And the more people do that, the more secure it is for everybody. I can also send some blog posts to explain the whole thing. And one more thing is that the phase one takes takes about a day to complete, and it's very intensive on your computer. It can take 18 to 24 hours to run, and requires a total of 150 gigabytes of bandwidth. So you need to download 47 gigs and upload 97 gigs. So it's quite intense, and but so far we have like 40 plus people who have done it since last year.
For example, with MACI and Semaphore and Perpetual Powers of Tau, could you like use all three of them together, or like a combination?
So the Semaphore trusted setup, the phase 2, uses part of the Perpetual Powers of Tau. So phase 1, Perpetual Powers of Tau, phase 2, Semaphore. And for MACI, we take Perpetual Powers of Tau, and then we do a MACI phase 2.
I mean, like if you want to run some sort of voting election or some sort of voting process, would you be able to combine like the fact that MACI allows the bribee, the briber not to know what the bribee is voting on, and how Semaphore allows like no one else knows who votes for what? Would that be able to be combined?
I think so. In MACI, only the coordinator knows who voted for what. If you want to combine it such that even the coordinator doesn't know who voted for what, and have to think about it. Yeah, it's something to think about. I haven't really, but that's a very interesting idea. That to add anonymization to MACI, I think it's possible, but I have to do more research. Yeah, I think I think Koh Wei Jie, who is part of the team, has written something about it, but I haven't really gone into that myself.
Okay, so like going back to MACI just now, what kind of help or input would you need from the community as a whole so that we can make it get more advanced?
So currently we are looking for developers who can spend like a few weeks, full-time or part-time, to do some tasks to implement some features into MACI. And so that's one way that people can contribute. Yeah, because there are some features that sort of like would make MACI version 1.5 or even version 2 that we encourage people to contribute to, but we are still looking for folks to take on these bounties. So these are compensated mini projects that we hope to find people to do.
What kind of skills are you looking for? Sorry.
Solidity, smart contract development, understanding, to be able to write Solidity code and to have a basic understanding of how MACI works. Yeah, which is something they can learn while doing. Yeah.
And so earlier you mentioned like for an election as a whole, MACI only plays one part. There's other parts that need to be developed, like identity, key management, I guess getting some sort of privacy from the coordinator. Are there other parts as well that need to be developed simultaneously?
User interfaces is one, and that's currently being worked on.
When you say UI,
could,
sorry, when you say UI, like, is it any different than any kind of like, let's say there was an online voting website right now, like, would there be any difference between that and this?
it would have to be
Web3?
So it have to be Web3 right now. Right now, it would have to be Web3 because we have to do transactions to Ethereum, to the smart contract, to cast a vote or to sign up. That's, yeah, but yeah, some work has to be done in that area. I think something that is also quite important to touch on is the key management, because for ZK Snark applications like MACI, Semaphore, even Loop Ring and Tornado Cache, these applications all use a different kind of key than your Ethereum key. Your Ethereum key is called an ECDSA key, but for ZK Snarks, a lot of these applications use EDDSA keys. And currently, there's very limited support for MetaMask or other wallets to support that. So developers of the UI have to kind of get around that and use other methods to store keys and to do key management, which is quite difficult. Yeah, I think that's something that not just for MACI, but also for other projects that do ZK Snarks, for privacy or scalability, would have to figure out.
From the user point of view, is there a reason or a huge difference between the different types of wallets?
From the user point of view, your Ethereum key is something you use to create your Ethereum address, and then you can send tokens and ETH to the address. But your ZK Snark related key, the EDDSA key, is not necessarily something you use to send and receive funds. For example, in MACI, it's only used for voting. But in other applications like ZK Rollup, you might use that key to receive funds on the layer 2, in the layer 2 rollup. So it really depends. And I think there's a lot of user education to be done to clarify this.
Okay. And last question for me, I don't know if others have other questions. On my end, other than what you mentioned earlier about getting help to develop the software, I guess, what steps can we as a community take to help it get applied by like real world or outside of crypto entities?
Oh wow!
Some sort of lobbying group.
I think crypto has to. Wow. I think MACI is I think we have to first find the solution to get crypto adoption in general before we can even talk about doing MACI stuff, because it's too early. Yeah. But it's not impossible. Like, I think for crypto adoption, I've heard of like crypto-based games getting very popular, even for people who haven't already involved in crypto. Yeah. So it's not like impossible. I think there's a good chance that slowly it will happen.
I guess if I flip the question slightly, how can we get it to be applied more by crypto entities like DAOs and other people?
Wow. I think there has to be a good track record of MACI solving bribery problems. Currently, a lot of bribery, there's some collusion that happens with the Gitcoin grants, and this has been flagged up by Gitcoin themselves, and they are very aware of it and they talk about it. I think if we can if the teams who are working on quadratic funding with MACI can succeed and demonstrate that they have this mechanism that's working, I think that's when we get interest to further develop on different use cases. So I think that the answer is a combination of two things, which is a need and the track record. There has to be a need to prevent collusion, and there has to be a track record of MACI working.
Okay, cool. Yes, if anyone else has any questions, otherwise, Widget, like if you, for any discussions, like what were kind of points that you would like to say, get any input on?
Yeah, I would like to hear about, besides quadratic funding, I'm quite interested in applications for DAOs. If anybody is part of a DAO and they are aware about collusion, or if anybody's like in the crypto community is like aware of like other instances of collusion, I would love to hear about those experiences and those stories. And I would also love to hear any kind of like out of the box like applications for voting that could be used for MACI. Yeah. So I think that's something I would love to hear. But I'm also open to any other questions.
I guess when you say collusion, sorry, Roman, I'll mention this quick. And this is not Ethereum, obviously, but you hear about how these sort of depots, delegated proof of stake chains have these kind of, I don't name names, but like EOS is largely mentioned as how the consensus pretty much has become like a one country dominated. And I don't know if that counts as collusion, but that will probably be one good, if we can get stories from there.
Wow. That would be quite interesting to think about in a MACI context.
Yeah, so if anyone is from EOS or is active in that space, they can share. For anyone watching this video later. Rahman has his hand up for a while, so go ahead, Rahman.
Yeah, sure. Yeah, thanks for the presentation, Wei Jie.
Hi,
I still have a kind of a bit confusion around your voting. You said that the voter can cast several votes, and some of them can be valid and some can be invalid, right?
Yeah.
So, like, how in the end do you ensure that only one vote, or like the last vote, is being accounted for? If you want to introduce that constraint.
We currently count all the valid votes, so not just the last vote. And
so basically,
let's say my first vote my first vote is 5 points for party A, and second vote is 2 points for party B, and my third vote is invalid, but counts like 3 points for party C. At the end of the day, only the first two votes will count.
Why? Wait, so you casted 4 votes, didn't you, just now?
Let's say cast 3 votes, right? Okay, 3 votes.
Okay.
Two valid, 1 invalid, right?
Okay, so 2 will be considered valid, right?
Yes.
But okay, so is there a way to just like say you're voting like the same way you vote in elections, right? You don't vote by points. You just like pick one option, right, out of different candidates, right? So like, how do you how do you recreate that scenario? Like, how do you ensure that there is, in the end, only one vote that is being counted for one of these candidates?
So only one vote. So you can only choose one candidate. Is that the idea?
Yeah. Yeah.
Yeah. So we have to modify the MACI logic to make that happen. But you only need to do that. And so this is a kind of a kind of voting that is also possible to do with MACI as long as you modify MACI. MACI's from the version that we currently have is the quadratic voting version. The single vote version, we haven't done that, but it's possible to do as well. You just have to change the code. It's moderately difficult because you have to modify some of the off-chain vote counting logic, and also modify the zero knowledge ZK SNARK circuit, which takes some time and takes some understanding. That is possible with some effort. Yeah.
Cool. Okay.
And I'll be happy to give anybody any pointers on how to get started with doing that. Which is like zero knowledge circuit coding in general.
All right.
We have some questions in the chat. We asked for who is to decide how many votes I cast and how many would then need to be valid. And if I purposely invalidate my proofs, will I be penalized?
You can cast as many votes as you want. However, there is the limit comes in as a setting in the system. Basically there's a Merkle tree of votes, Merkle tree of encrypted votes, and the capacity of the tree is what commonly limits MACI. And so as for invalid proofs only the coordinator is in charge of creating proofs, and they don't get penalized for publishing invalid proofs. And there's no reason for them to be penalized, because they can themselves check whether the proof is valid before they submit their transaction. So no one would ever submit something that would penalize themselves. The idea is that the counting process can only proceed as long as the proof is valid. So let's say there are 1,000 votes, and we count the votes in batches of 100 each. So they have to provide 10 proofs, and each proof must be valid in a chain, and the chain must be in the correct order. And then you count it 100 by 100. At the end of the day, you have the result of all 1,000 votes. And you get stuck if you don't provide the next proof. So as long as a coordinator, we assume that they provide all the proofs in order, and the smart contract ensures that they'll be valid, and the smart contract ensures that that it is in order, and they can't do anything else except not do it at all. They can only do it one shot or correct, or they could just do nothing. But we assume that they won't do nothing.
Ray asks, are votes anonymous, or are they tied to a voter ID/key?
Yeah, each vote is tied to a voter's key, so they're currently not anonymous. But only the coordinator. So only the coordinator knows the key, the public key, but other voters don't know because it's encrypted.
Okay, so since you mentioned out-of-the-box ideas, and we're 3 minutes before 9:30, I think it would be a good time to kind of just end it soon. There were some ideas mentioned by the Meetup attendees before the Meetup. So maybe just off the top of your head, just give your take on whether it applies or not. So one of them asked if we can somehow use MACI in voting to decide the next DevCon location.
Wow.
Would that be practical?
I think it's practical because it's because the people who vote are scattered around the world, and it's hard to do like in-person collusion. And it's a very simple kind of yes, no, not yes, no, but it's a very simple kind of vote. It's just, here are the list of locations. I think that the challenge would be who's eligible to vote? How do you define that?
And I guess you can do like quadratic voting to make sure that the rich whales don't have like huge power to shift it in one direction.
Yeah, that's one way. We could use that we could use quadratic funding to not make rich whales skew the vote. But we also could use other mechanisms, like, for example, you go to DEF CON or other Ethereum hackathons, there's this thing called the Pope token. It's an NFT that you physically receive from the POAP team, and you scan it and you redeem your NFT. And then you could, if you own an NFT, you could be eligible to vote, for example.
Which, by the way, in case people haven't been checking the chat, we are giving POAP badges, NFTs,
nice.
For anyone attending, as long as they want to, because I think right now you have to pay the gas fees yourself. So, but I can send you the unique code and you can claim it later.
Oh, nice.
Just saying that before I forget. Raman asks, shouldn't all DevCon ticket holders be eligible to vote? I think that's related to what Wei Jie was saying. Like, if you've been to one event before, or even not just DevCon, but other events, and you have, let's say, a POAP NFT, then you can use that as some sort of qualifier to be allowed to vote.
Yeah, at DevCon they gave out the Pope tokens too, so you could use that.
I guess people can still like farm the tokens and then create multiple addresses to vote from, but yeah, just ways people will gamify it.
You have to trust the Pope team to only give one token per person.
Yeah. All right, guys, that's enough shilling of gas stuff. And then so one idea is also, and I don't know if this is relevant, whether it makes sense, but let's say for prediction markets, because in some ways it's sort of a vote on what will happen. Would there be any reason to use MACI there or not?
It sounds like a really interesting idea, because if, let's say, the prediction is about some person and that person could try to influence the market using bribery, yeah, maybe this is a good use case. Sounds interesting.
Okay.
I never thought of it myself, but that's fascinating.
Okay, and then okay, sorry, 9:31. But I think just last one, at least for me, is like what is your most out of the box idea that either you came up with or you've heard of so far?
Wow, mine. I think the quadratic dollar homepage is the most out of the box idea I've heard. Up to today, I think today the most interesting idea that was actually the prediction markets idea. I should spend more. I would love to think more about that.
Okay.
Yeah.
Credit to ETL for anyone watching.
Yeah. Thank you so much. Yeah.
Yeah, no worries. I guess thanks to the community. Does anyone have any final questions or comments? Matthew says thank you. Yeah, a bunch of people are saying thank you. If not, I guess, thanks Wei Jie for coming, dialing in for our meetup here. And as Quentin said earlier, feel free to come again. I'm sure there's many other topics you can share on, and hopefully we can share input on as well. Thanks Wei Jie. And anyone who wants the Pope token, if I have your Telegram already, just ping me on Telegram. Otherwise, drop a message in the chat, and then I will get your Telegram and send it to you. Only if you want to. Otherwise, yeah. Any final words, Wei Jie?
Yeah, thank you so much for having me. It's a really great pleasure to be able to present. And hopefully, when all this, when the pandemic blows over, we can see each other again in person.
Yeah, cool, for sure. Come up the border and not have to wait 14 days.
Yeah. Yes.
Yeah, okay. Everybody feel free to say thank you to Wei Jie in the chat, and I hope Wei Jie you can figure out the chat, because otherwise he can't see what you guys are saying anyway.
I can see now. I can see
okay.
now. Thank you so much.
Yeah, and before we go off, since Jason's here, like I mentioned at the start of the meetup, the Southeast Asia DeFi Week #2 is happening from the 10th to 18th. So if you guys are interested, feel free to sign up on Eventbrite, which I will share in the Telegram group. And if you're not in the Telegram group, let me know. I can add you in there. And there's a bunch of talks by DeFi projects. And I think it's once a day. So feel free to check it out. Otherwise, we will see each other next month on the first Thursday. Let me know what topic you guys might be interested in discussing. Right now, I'm looking at either discussing yield farming, since that's hot, or blockchain/IoT. So, of course, Johnson says yield farming. Actually, no, okay, also IoT. All right, otherwise, thanks guys for coming. It's 9:34. I think it's a good time to end. And thanks again, Wei Jie. See you guys.
Thank you very much.
Bye, guys.
See you. Thank you.